AS9145 just came out a few years ago, but it's picking up steam. It's based on some automotive standards for advanced product quality planning, and it combines the PPAP. And what you see in the bottom is the automotive guidelines for advanced product quality planning and the production part approval process. And it's simplified and made it a little bit more practical for the aerospace industry in this AS9145 standard. So the automotive industry's been using these tools for over 25 years, and there's many other industries that use APQP and PPAPs because of it's a good practice. It's been around a long time. The aerospace industry had to come up with their own because of the lower volumes, because of the higher regulations, and we know that aircraft can fly for many decades, and there's unique differences that needed to be accounted for with the aerospace industry. So what we want to accomplish in this webinar is give you a basic understanding of the APQP, Advanced Product Quality Planning, and talk about who's asking for it in the industry, and give you an understanding of the relationship between what aerospace is doing versus automotive. And there's a lot of free information out there. I'll be going through that in this presentation to give you some free tools, free training, further training, and a lot of the details. So that's what we're looking at to accomplish. So who's asking for PPAPs and APQP? This was a list from about a year and a half ago. Not intended to be a comprehensive list, but you can see some of these customers have begun asking for PPAPs and APQP from their supply chain. When we talk about advanced product quality planning, the purpose is to provide a structured approach with expected outputs, records, to show that you're proactively working product development and process development life cycle using cross-functional teams, and ultimately gaining value and being more proactive in the new product development process. We see one example with one company that shared their experiences with PPAPs. And what you see on the left is a chart that talks about those programs that used PPAPs and those programs that didn't use PPAPs. So PPAPs are an output of the APQP process of the Advanced Product Quality Planning. And they saw a 40% reduction in rejects, defects, when their programs used PPAP. And then on the right-hand side, when they were doing work transfers and requiring PPAPs when they transferred work, they saw an 80% reduction in problems, rejects. So there's great value and proven history. This is an aerospace example. The automotive industry's seen similar results by being more proactive and using a phased, structured approach. Ultimately, this results in more successful new product launches, and it makes the customers happy. Fewer problems, reduced waste and warranty issues, help managing risks. So other benefits of the APQP process: making sure that we understand the customer's expectation and ultimately meeting their requirements, but also taking out costs and having a more robust process for new product development and also manufacturing process development. And when we do things from a planning standpoint, more proactive standpoint, we have fewer changes because we're doing it right the first time. And ultimately, this is all, benefits that we see out of this process. So enough of selling. APQP, Advanced Product Quality Planning. This is a model from the IAQG, starting at the top with the needs and trying to show the phases of the APQP with planning, the design of the product, the design of the process, the manufacturing process, the validation of the product and the process and production. And then the output is the PPAP that the customer approves to allow you to go into mass production. So breaking this down a little bit deeper here with the pyramid here, there's 5 phases to the APQP, and for each of these phases there's expected elements that will exist, or activities that will occur. And from each of these phases there are some key deliverables that will end up in the PPAP package. So when we look at this a different way, we see that the 5 phases of APQP, we see planning is the first phase, product design and development is the next, process design is the third, the product and process validation is fourth, and then production is last, and post-delivery. So those are the 5 phases, and we can see, going left to right from a timeline perspective, the concept from new product development, the preliminary design review, all the way down into to the product launch. And we see the different levels here, where at the bottom the PPAP is occurring at the tail end here, where we're looking at the validation. Going right before we go into full production is when we do the PPAP and deliver that to the customer for approval, so that we can go into mass production. There is a lot of information in the Supply Chain Management Handbook. There's a couple of slides, if you're not registered, that'll go through and tell you how you get to some of this information. But there's a lot of information here on the Supply Chain Management Handbook with APQP. We see a bunch of webinars. These are all recorded, free webinars going through the different elements of APQP. There's some guidance documents and a lot of tools and templates for doing APQP and some of the key deliverables. So it's a great resource, free information. Recommend that you check it out if you haven't. But what I'm going to be going through in this webinar is going through these 5 phases and what are the expected deliverables out of these phases. So as an example, with the planning, we have inputs for the project, but on the design side, there's going to be a design risk analysis, identification of any key characteristics, and as we get into the process design, the manufacturing process design, we're going to have a flow diagram for the manufacturing steps, like Operation 10, 20, 30, the process failure modes and effects analysis. And so we're going to go through this in a little bit more detail to give you a little bit more awareness of some of the elements that are ultimately going to end up in the PPAP package deliverables and what has to be submitted to the customer. So this first phase with planning, what I have in bold type are expected records, and what's just normal type are just typical elements that you might find in the planning phase. And then where in the next side you'll see some red type, and that'll show you what's going to be required in the PPAP package. But for companies that don't design products, some of these items won't apply. The expected pieces that you'll have for this planning phase will be less if you don't design a product. If you're just making to print, there'll be less pieces here. So the second phase is designing of the product. I'm not sure how many of you are designing product, but if you do, there's a requirement for design risk analysis, which would be a design FEMA. That's the first deliverable in the PPAP package. The failure modes and effects analysis, and I've got a couple slides to go through that here in a second. But there'll be design records that are expected, drawings, specs. Critical items and key characteristics important in the aerospace industry for more complex products. And these are things that we would expect to see some kind of records for. If you're making parts to print, these would be identified to you by the customer on their drawings or specs. All right, it's an example of a design FEMA. Looking at this flashlight, this mag light, they're wanting to see from a design perspective, what is it supposed to do? What's the function? What's the primary function of the flashlight? And then looking at each unique part, you can see the 16 parts in this flashlight. The design FEMA will look at part number 1, part number 2, part number 3, look at how it can fail, and then look at the components and subassemblies, how parts 1 and 2 go together, and 3 is a rubber bushing, 4 is a spare bulb and the spring, and how those go together into the housing number 6, and looking at the functions and the subassemblies issues that could occur there, and then populating that into a template. So this design FEMA template looks at, if we look at the function, the function of the flashlight is to illuminate a targeted area or a dark area, or direct the light at a source. So this design FEMA template will look at, well, what can happen for the flashlight not to function. It just doesn't work. Or if the flashlight has partial function, or if it has intermittent function, or loss of function over time, or unintended function, and then it looks at the potential causes of those failures and how serious those might be, the severity, and scores the severity, looks at how likely those problems could occur, and applies a score of 1 to 10 on the likelihood of occurrence, and then looks at our ability to detect this in the design and or prevent it in the design, and we come up with a detection score on 1 to 10. So we multiply the severity times occurrence times detection and come up with a risk priority number to evaluate whether the risk is acceptable or the risk is too high and we need to make some changes to mitigate those risks or reduce those risks. So these are great tools for helping to identify and understand when a risk is okay as it is and we don't need to take any action, and then when those risks are too high and we do need to do something. All right, the third phase gets into manufacturing process design, and as we're making product, we have to plan, and especially if it's a new product and we have to put in a new production line or new equipment, there's a lot of planning that they want to see from a proactive standpoint, starting with what's this line going to look like? What is the process flow? What's operation 10? What's operation 20? What's operation 30? What's the floor plan look like? And then they want to see a process failure mode and effects analysis, similar to what we just looked at on the design side. Again, the bold type, the black bold type are expected outputs or records that they would want to see. So if there's any key process characteristics, and then the red items are what has to go in the PPAP package. The control plans are developed at this phase as well, and what we want to see is the flow diagram feeds into the process FEMA, which feeds into the control plan, and I have a chart on that in a second. And then we see, we could have gauge R&R studies, capacity assessments, supply chain risk plans, all of this proactive planning. So process flow diagram, one of the outputs that they want to see in the PPAP package could be as simple as, showing operations 10 through 70 here, from the receiving of the raw materials to the shipping of the product is the starting point and the ending point of what they want to see in a process flow diagram. In the supply chain management handbook, this is one of the templates that they provide, and I like this template because again, it's operation 10, 20, 30, 40. Each row here is different steps, and then they break down whether it's an operation step, a setup, a move, a store. But I really like showing this when there's in-station rework. So here we have an inspection and test, and then if there's a problem, they can rework it, and it's part of the process flow, and you can see that. I like that in this template. Too many companies don't account for the in-process rework steps in their manufacturing production processes. The process FEMA template looks very similar to the design FEMA, but it's a different structure where it looks at each process step, operation 10, operation 20, operation 30. And in operation 10, it wants to see what can go wrong, what are all the potential problems and the effects of those problems. But then we get into the causes and look at the severity, the occurrence, the detection, and come up with a risk priority number. And when the risk priority number is too high, we have to come up with subsequent actions to help manage and mitigate those risks. And so this is a proactive tool in the design of your manufacturing process to say, hey, we've identified something that could occur, the risk is too high, and we need to do something to manage that risk or to reduce that risk to an acceptable level. This is a template that is in the Supply Chain Management Handbook. Similar template, and my templates, there's some, anything that's not in the Supply Chain Management Handbook, any templates that I'm showing and have are accessible for free. I'll give you a link to those. There's no sign up, or you just click on the link and it'll take you there and you can download them for free. There's no tracking or anything. I talked about the linkage flow diagram feeding the FEMA, process FEMA, feeding the control plan. And all of those are planning tools to create better, appropriate work instructions and setup instructions, and then any inspection and test templates and forms. So doing those, using those tools and planning really help drive more effective production work instructions and setup instructions and the inspection and test tools. The fourth phase of the APQP is the validation of the product and the validation of the process. So here's where we're going to do gauge R&R studies, gauge repeatability and reproducibility studies, also called measurement system analysis. Process capability studies, where we have key characteristics or critical items that the customer may identify. We may have to do SPC, which is a process capability study to show that we can make the products within statistical capability. We also have our FAIs, our first article inspection reports, as referenced in AS9145. Control plans we talked about, and then the actual building of all of this is all building up in the PPAP package. So gauge R&Rs, I probably have too many slides here on gauge R&Rs, but once you design a manufacturing process, design a product, it's hard to design the variability out once you've designed it. And so when we look at measurement techniques, there's variation in the people, the variation in the gauge, and we want to make sure that we call a good part good and a bad part bad, and we never have bad decisions made by calling a good part bad, or worse, a bad part good. So gauge R&Rs are important in that regard, and it takes into account all of these different variables in the measurement system and the usage of the gauges and the measurements that we do. So this is a template for a gauge R&R study for a variable gauge, and it would take up to three operators, looking at 10 parts, and the operators would measure parts 1 through 10 three times, 2 or 3 times. You could do a shorter study. You could there's different variabilities here where you could do 2 operators versus 3. Instead of measuring the 10 parts 3 times, you could do it 2 times. Just it affects the numbers and the statistics behind the gauge R&R. But ultimately, you come up with a study that comes up with a gauge R&R percentage, and it looks at the gauging systems and the variability in the equipment, the variability in the operator, and also the part variation. And what we want to see is a gauge R&R under 30, ideally under 10, and there's other factors and things behind here that we don't need to get into. They also want to see with attribute gauges, pass fail, go no go gauges, check fixtures that are, what you would like mylars or laying apart in with boundary samples. They would want to see that different operators would look at about 20 or 30 parts in 2 trials and see that they get consistent results, and that they can catch the bad samples using the gauge, and making sure they're calling a good part good and a bad part bad. And there's more, if you're using Minitab or other software, there's much more sophistication that'll go on behind here. These are very simple templates and tools that can be accepted by the customer for an attribute gauge R&R. And again, these will be on our download website. Process capability studies is statistical process control. Any key characteristic identified by the customer, or critical items are safety critical, mission critical, flight critical. They just want to see that we're statistically controlling and managing and can make parts consistently within spec to an acceptable variability. And then all of these are starting to piece together the PPAP package, the production part approval. This template, don't use the automotive template, because the automotive template has 18 elements, and this one has 10 with one more with this actual PPAP approval form is 11. But if you don't do design, number 1 and number 2 go away. And so if you're just making parts to print, it's 3 through 10 plus this form. So this is what the PPAP looks like. And your customer may also dictate or give you their own forms to fill out on all of this. It depends on the customer. Ultimately, when you're submitting this paperwork along with parts to the customer to approve you to go into production, they're going to either approve the PPAP and say, yep, let's go ahead, you're full steam ahead with the production, or they may give you interim approval where they say, hey, Kate, this is fine, except, gee, I saw this process capability on this characteristic and we didn't like it. We want you to be tighter. Work on that and resubmit. Or they're going to reject it and say, we don't. They'll tell you why they're rejecting it for whatever reason. But those are the dispositions that you get back from the customer, and so these are the elements of the PPAP package. The right-hand column shows which phase those records would get developed in. And I like the aerospace approach because they've taken out a lot of, in my opinion, a lot of automotive waste an excess and have done a good job making this a little bit more streamlined. And then the last phase is production, and ultimately we want to see that we can make product to the appropriate quality levels and the appropriate process capability, and that we can make the right quantities that we targeted for, and we can deliver on time. So the project then it gets closed out, and then we get feedback, and we may go back and adjust the FEMAs and the control plans based on feedback that we get from the customer after the product's in production. So it is a cycle that comes back. But this lays out the 5 phases, the key deliverables of the PPAP at the bottom part of this chart, and hopefully that gives you enough information at a high level, and you can go and get more training on the specific elements if you need more information or training. Now, the aerospace industry, I really like this, different from the automotive. The aerospace industry has been using a maturity model with their suppliers, the APQP maturity model. This template comes from the Supply Chain Management Handbook, but I've seen in practice some of the primes and subprimes a much simpler maturity model, basically trying to understand the supply chain risk on how sophisticated they are in doing FEMAs and doing control plans and doing process flow diagrams. And what I typically see, excuse me, is a much greater focus on the usage and sophistication of the APQP tools, and looking at how mature the companies are, suppliers are. So as an example, some of the maturity model examples is on the failure modes and effects analysis, looking at 5 levels here. The company's not doing any FEMAs. They have no idea what a FEMA is, all the way to they've got a very structured approach in place for FEMAs and maintaining FEMAs and updating them and making improvements over time. So everything in between. So the same thing with other elements of the APQP, and looking at the sophistication, and then the customer can work with the supplier. What I've seen is the supplier will score themselves, and then the customer will come in and score and look at the differences and make adjustments. But then the customer can also identify this as a supplier development need, or accept the risk and say, yeah, we want you to get better over time. And then they understand their risks about the sophistication of your APQP competency. So this is the end of the presentation. I hope you've gotten a good understanding of the APQP, and the Supply Chain Management Handbook is great. But I also want in the presentation there is this link in the handouts. You can go here. I'm going to just do this real quick. This link here. It won't work in the presentation here. It's all right. I'll take you there in a second. Let me see if I've got it open or not. I don't have it open. Let me just get out of here real quick. There we go. Oh, it's not going to let me go there. Oh, it's because I'm not in the right place here. Sorry. Let me go here. So this is just our website. There's a different example of an APQP maturity model that's simpler than what's on the Supply Chain Management Handbook. A DFEMA template that's really nice with comments, and a PFEMA template with cells that explain a little bit more detail than just filling out an Excel file. It actually helps you with tips and guidance and ideas, and then a couple of gauge R&R templates. So it's just another tool to look at and consider. Oops, here we go. So that's all that I have. I'll open up the floor for questions. I kind of went through this pretty quick.
Thank you, Jim. I'll monitor the chat feature. So if anyone should have any questions regarding the presentation that Jim has just completed, by all means, please either turn your camera and mic on to ask it, or you can ask it here within the chat feature, and I'd be more than happy to relay it to Jim. So Jim, while we're just waiting, I have a question. Are you seeing the flow down of APQP PPAP within any contractual requirements from some of the primes to their suppliers?
I am, yes, a lot. Lockheed Martin, L3 Harris. I've seen it in Boeing's case, and different approaches with that. But I am seeing it with customers.
Okay. And then Nin has a question. Nin, go ahead. You can turn your mic on and ask.
Okay. Hi, Jim.
Hi, Nin.
Thanks for a good presentation. I appreciate it.
Thanks.
Are you familiar with the sourcing deal called exometry, where you can put quotes out and get quotes back from the internet? And have you heard of this being flowed down using that type of quoting disbursement?
Yeah. So what if I'm not mistaken, what you're asking about is like free markets online, reverse auctions online to bid business. Is that right?
Correct.
Yeah. So I've actually used that tool many years ago when I was in a sourcing and supplier quality role, and we did that, and we flowed down PPAP requirements as well. So yes, the answer is yes, and that was in a non-aerospace, non-automotive industry where we were using the reverse auction on the internet to buy parts, source parts around the world. And then when we went to a new supplier, we were requiring PPAP packages and expecting to see the elements of APQP put into place.
So okay, so it's not uncommon to do that then.
It is not uncommon at all. No, it is actually recommended, especially if as you go to new sources or you're trying to improve and develop your existing sources. Let's say an existing source wins the internet auction. Which happens in our case, that happened about 50% of the time, and they might not necessarily have been the lowest bidder, but based on risk, based on technology, based on geography, there were different variables that went into play. We didn't just go off of cost, but if we had an existing supplier that didn't have the APQP sophistication, we were wanting them to redo PPAP packages on new parts.
Very good, thank you.
So Jim, I have another question.
Yes.
Within the aerospace industry, we have our first article inspection FAI requirements. So within the automotive and now the adoption of PPAP, that's what I normally would see as a full layout under the PPAP process. What relationship or synergy do you see with PPAP and FAI? Do you think PPAP is going to replace FAI, especially with the FAI standard that they released? I'm just kind of curious, what synergy is there going to be between those two?
Yeah. So the synergy is that in the automotive industry, the PPAP package includes a dimensional study, which is an FAI, and so what's missing from the APQP package for aerospace in AS9145 is the FAI. Let me just go back here. Is the FAI in that deliverable? Because what we didn't see is the FAI. Let me see. The FAI is a deliverable in the PPAP package for AS9145. So it is equivalent to the dimensional study, that we see in the automotive industry.
Okay. All right, I was just curious.
Anybody that's online, have you seen AS9145 flowed down yet from any of your customers? I apologize for my coughing disaster as fighting this head cold, summer head cold. Well, thanks everybody for participating. I appreciate your time and hope you got value out of this session. It's been my pleasure. Yeah, Nin, you have another question?
Yeah, just following up on Sam's question about AS9102. So, is it safe to say then, or is it not safe to say then, that having a PPAP AS9145 requirement flow down and AS9102 flow down to the same supplier, is that redundant, or is that overkill redundant? Or can AS9145 suffice in and of its own without the 9102 requirement, or what do you see there in reality?
So if you think about AS9145 being APQP for the whole methodology, and the deliverable being the PPAP package to approve the production part, the PPAP package includes the FAI. One of the line items that, let me go back to share my screen. One of the line items in the PPAP package, right here, is the FAI. Number 9 it's the FAI. So the dimensional analysis from the FAI is one of the deliverables for AS9145, along with these other items.
So in that step 9, then you reference AS9102, or is that overkill?
Oh, you could reference AS9102 if you wanted to follow that. I think it's not overkill. You could do that.
Are the deliverables in 91 are the so AS9102 has its own deliverable forms and format?
Yep.
Is the output of number 9 within AS9145 similar or the same in its output?
So AS9145 is not a very large document. It's a very high level document, and doesn't get into the details. The AS9145 does not prescribe any of the templates that I showed you. It is simply going through the structure and the theory and expectations, and it has some tables of what you might expect to see as outputs of these steps, without giving you what it looks like or what it has to look like.
Okay, so then putting a 9102 requirement in step 9 then would provide structure.
Yes, would provide structure. Yes, to your supplier, it would provide structure.
And consistency of cost.
That you want to see a 9102 format. Yes.
Okay, so they dovetail together well.
Yes, exactly. Yep.
Okay, very good. Thanks for the clarification.
Yep, no problem.
So, Jim, in your support of organizations that are now implementing PPAP and APQP, out of these 1 through 11 elements there on your chart, are you seeing that aerospace organizations are having some difficulty with possibly control plans and MSA?
Yes. Yes.
And what is it that you would recommend an aerospace organization that's partaking in this endeavor to take a look at or to do to make it an easier implementation?
So, great question, and the answer is yes. I am seeing aerospace companies having difficulty adopting the APQP because it is more work. It's extra things that they've not done before. There might be pieces, but like a process flow diagram. They know the production steps, so they know they're going to do this operation, then that operation, and it might be in a traveler or a router, and it lays that out. But they might not necessarily have a process flow diagram that strips it out at that a process flow diagram level. or FEMA's and control plans are, and MSA, the gauge R&R studies are time consuming, and if you're already making the parts, doing these after the fact are not as value add, and it's but for brand new products, being proactive, it's a great tool. And you may learn some things already making products by going through. And I mean, we've done these with companies, many companies that are already in production, and then and have been for many years, and then go through and help them create these documents. And they find, oh my gosh, now we've scored this, and we realize, we've been fighting this problem, and when we score it and put it into the risk priority number of the FEMA, we realize and see that this is an unacceptable risk, and we need to do something more to reduce the risk. So it becomes it's like, kicking yourself in the head and saying, we intuitively knew this, but now we've quantified it and said, we do have to do something about this, because, we've been fighting this, we've been living with this problem, and, it's something that, we identify as too high of a risk, and we shouldn't be dealing with this. It is you will go through, you can go through the training that's free on the supply chain management handbook. But what we have done from our perspective is facilitation, where we actually train and do the FEMAs and the control plans in a workshop and exercises with the team. And you can get them done. You can get a FEMA or a control plan done in a day versus take you months, doing it on your own and fighting. And we do this all the time for companies in the aerospace and the automotive industry, and have been doing it for a long time.
Excellent, thank you.